Continue from last time, but this time we're going to talking about something else. So since we talk about that, when we have a bell curve, we are able to know, okay, where's the 1 standard deviations, 2 standard deviations, and 3 standard deviations. I'm just do a really bad sketch. Yeah, hopefully you can see it. Then, so this is my mean, this is my 1 standard deviation, this is my 1 standard deviations away, 2 standard deviations away, and 3 standard deviations away. Okay. But sometimes if I have a data, it may not that nice to be lighted like on top of the, for example, 1 standard deviation away mark or the 2 standard deviation away mark. Sometimes I might have a data that is sitting in between the 1 standard deviations above the mean and the mean. Then what do I know? Like how can I figure out where is this located? Where is this point located? Then to find it, we're actually going to using something called a z-score. You can think about this as a locator, talking about exactly how many standard deviations above or below the mean. This how many standard deviation can accurate in not to whole numbers, not to halves, can be very, very accurate into like decimals. Okay, so now I'm going to erase this whole graph. I'm going to draw a more nicer one again. Oops. This time, I'm going to label it in terms of numbers. Okay, so those are corresponding to the one we had before. This is the mean. Those are the 1 standard deviation away from the mean, 2 standard deviations away from the mean, and 3 standard deviation away from the mean. Okay. Then I can representing those as my z-scores, or the standardized, no calculation involved z-scores. So if I have a data that is exactly 1 standard deviation above the mean, I will have a z-score of 1. If I have a data is exactly 1 standard deviation below the mean, I will have a z-score of -1. Then if I have some other data is not on the mark, I can find the z-score by using the data x minus the mean over the standard deviation. So that is the formula to find the z-score. The data minus the mean and divide by the standard deviation. For example, if I have a mean is 100, and then my standard deviation is 15. And I want to know, okay, how about my data x is 130, for example. Okay, what is the z-score for the x equals to 130? Where is it located? So if you want to do it by drawing it, I'm just do a really quick sketch. I shouldn't pick 130. I'm going to erase it to 120. So again, labeling them, this is the mean, this is the 1 standard deviations away, 2 standard deviation above, 3 standard deviation above, 1 standard deviation below, 2 standard deviation below, and 3 standard deviation below. Okay. So 120 I know is located here. But what is the z-score? Then to find the z-score, we can do using the formulas that z is the data, observed data, minus the mean and divided by the standard deviation. Which is 1.3333. So this is 1.3333 above the mean. Just in case you didn't catch how I got those numbers. First, 100 is just the mean. Then 115 I using 100 plus the standard deviation. Then 130 I using 100 plus 2 standard deviation. And 145 I using 100 plus 3 standard deviation. 85 I using 100 minus 1 standard deviation. 70 I using 100 minus 2 standard deviation. And then 55 using 100 minus 3 standard deviation. Okay. So this is the z-score. Unfortunately, z-score you have to calculate it by hand. There's no technologies to calculate for you. There's no function to do this. But this one is really straightforward. You just have to know the formulas. You do need to know the standard deviation, the means, and what is your observed data. Okay, so that's it.